Alright, let's talk about chords and arcs. So let's talk about the first chord we know, or first chord you learned, and that's the diameter of a circle. So remember, the diameter of a circle is made up of two radii, and then we can put two radiuses off of this. And what we know is if we create triangles out of this, and this angle and this angle are the same, then the triangles have to be the same. So if I said triangle ABC, D, and F, those triangles have to be congruent. So triangle ABC is congruent to triangle FDC. We also know some other things. We know because like BC has to be congruent to CD because they're both radii. We also know that because these angles here at C are the same, because I said they were the same, we know that AB has to be congruent to DF. Or FD, actually. FD. And we can say the same thing about the arcs. Arc AB has to be congruent to arc FD. Oh, why did I put my arc symbol, not my congruent symbol? There we go. Oh, that's not very good either. Alright, so those are some of the properties we know about the basic chord of a diameter, and some of the arcs we can come up with off of that. Alright, so now we got a diameter and two chords. The diameter is a chord, so we really have three chords, but one diameter, which is more specific, and then two chords that are not the diameter. And the chord on the left here, I'm saying both sides of them are congruent. So we know that this right here has to be perpendicular. The chord and the diameter are perpendicular. So we know if we were to put some letters on this, let's call it A, B, C, D, E, F, and G, and H. We know that BG is congruent to FG, and that was given to us. What we don't know, or what we can't prove just on what we know, is that HC is congruent to EH. We just don't know based on the picture drawn, because I didn't put anything there that says that they're perpendicular, and I didn't put anything there that says that they are the same length. So we just don't know that they're congruent. So there's nothing you can prove with that chord. Alright, so let's work on finding the length of that chord. And we know that the chord and that line that's 5 make a 90-degree angle, and we know the radius is 8. Well, we can, because this is the right triangle, we can use the Pythagorean theorem and solve for what half of x is, and then multiply it by 2 and get what x is. So 5 squared plus b squared would equal 8 squared. I'm working the whole thing out, so this would end up being b equals, taking a shortcut here, 8 squared minus 5 squared. So if you've already learned enough about Pythagorean theorem, hopefully you can just do that. So it would be the square root of 64 minus 25. So 64 minus 25 be 9, 39, square root of 39. And the square root of 39 would give us square root of 39. It can't be simplified. And so we would multiply that by 2. So x would equal 2 square roots of 39. And there's nothing more you can simplify there. If you needed an approximation, you can type that into your calculator. So that'd be about 12.5. And I didn't put any units there, but so let's put some units. Let's call them centimeters, so it'd be about 12.5 centimeters. Alright, so let's do another one. So we're going to find x, and x is the radius. Now, this looks more complicated than the last one, but it's really not, because we know that x is the radius. So if I draw in another radius right here, and this makes a right triangle, then I know that that x has to be the same as this x, because they're both radii. So I know that whole chord is 10, so that means half the chord is 5. So now I can just use Pythagorean theorem, or if I and solve this. So that would be 4 squared plus 5 squared equals c squared. So c would equal the square root of 4 squared plus 5 squared. So c would equal the square root of 16 plus 25. So c would equal the square root of 41. And can square root of 41 be simplified? Let me check real quick. No, it cannot. So c is the square root of 41. If you needed a approximation, c would be about 6 4/10. So it looked harder when we first started, but just knowing those properties of all radiuses have to be the same. A diameter is 2 radiuses. And just remember those properties of triangles should help you solve all of these problems.